Hi students, in this video we will study about don't care conditions in boolean functions. You know that boolean functions are in two forms, SOP and POS form. SOP form means sum of product form, that is sum of minterms, and POS form means product of sum, that means product of max terms. So if a boolean function contains n variables, then there are 2 raised to n input combinations are there. That means 2 raised to n minterms or max terms are there. So in that 2 raised to n minterms, the SOP function contains only those minterms that will give output 1. All other minterms are 0. That means sum of those minterms whose output is equal to 1. And in the case of max terms, we consider those max terms, the boolean function consider those max terms that gives function output is equal to 0. Other max terms that gives function output as 1. Okay. This means that suppose we have a 2 variable function. The variables are x and y, input variables are x and y, and output is equal to 1. Then inputs are x and y and output is equal to 1. So we have 4 input combination 0, 0, 0, 1, 1, 0 and 1, 1. Suppose output is equal to 0, 1, 1, 0. That means for the 2 minterms output is equal to 0, and for the 2 minterms output is equal to 1. So here we write the expression as f is equal to x bar y plus x y bar. That means it is the sum of those minterms that will give output 1. Okay, and other two minterms gives the function output as 0. Okay, that means we consider all the minterms that will give output 0 or 1. Okay. But in some cases, there are unspecified minterms of a function, that is called the don't care conditions. Okay, some minterms are unspecified. For example, in the case of a BCD, you know what is a binary coded decimal? So binary coded decimal means it is a 4-bit equivalent of 0 to 9 decimal numbers. Okay, so we can represent it as 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, etc. up to 1, 0, 0, 1. So to represent the 0 to 9 decimal digits, we need 4-bit number, 4-bit binary number, and that is 0, 0, 0 to 1, 0, 0, 1. So in the case of a 4-bit 4 input variables, there are 2 raised to 4 16 combinations are there. But in this 16 combination, we didn't consider the 6 combinations, that is from 1, 0, 1, 0 to 1, 1, 1, 1. So these terms are unspecified. Okay, that means they are don't cares in the case of BCD. Okay, in the case of BCD numbers, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1 are the don't cares. Okay, that means that values are not specified. These don't cares are represented by x in the K-map. But while minimizing the Boolean function, we consider this x values in the K-map for grouping to find out the simple functions, minimal functions. Okay. Consider the first example. F is equal to sigma m of 2, 4, 7, 10, 12, and d is equal to sigma m of 0, 6, 8. So here d represents the don't care. Next we can draw the K-map. So this is the K map. So here it is AB, CD, 0 0 0 1 1 1 1 0. Here it is 0 0 0 1 1 1 1 0. So we can write the decimal equivalent 0 1 2 3 4 5 6 7, then 8 9 10 11, then 12 13 14 15. Okay, then mark the midterms. So here 2 4 7 10 12, right? Then mark X for the don't cares. 0 6 8. Okay, next we can do the grouping. The first group is this quad. Okay, second group is again a quad like this, corner elements. Then we have a pair. Next write the expression. Expression for this quad is, here AB cancelled, so C bar, D bar. Then for this quad 0 0 1 0, A cancelled, B bar. Here it is 0 0 1 0, C cancelled, D bar. Then for this pair A bar, B, here it is D cancelled, C. Okay, so our simplified expression is F is equal to C bar D bar plus B bar D bar plus A bar D C. Okay, so in this case we consider don't care also for grouping. Okay, but it is not necessary to group all the don't cares. Take only those don't cares that is necessary for grouping with ones. Leave all other don't cares as such. It is not necessary for grouping all the don't cares. Okay, that point you should remember. Okay, the same way we can simplify POS expression also. Suppose you have given an expression F is equal to pi m of 6 7 8 9 plus D of 10 11 12 13 14 15. So here this one is the don't care. Okay, so first to draw the K map. So this is the K map. In this K map, first we enter 0 for the max terms 6 7 8 9. So here 6 7 8 9. Then mark X for the don't cares 10 11 12 13 14 15. 10 11 12 13 14 15. Okay, next we can perform the grouping. So here this one form a octet, then here it forms a quad. Next we can write the expression for each group. So first octet. So in the case of octet, CD cancelled, then here B also cancelled, so only A. Here A value is equal to 1. So here in the case of max term, if A is equal to 1, then it is primed. So it is A bar, expression is A bar. Then for the quad, here A cancelled, B only, B is equal to 1, so B bar plus, here it is D cancelled, C only, C is equal to 1, so C bar. So the simplified expression is F is equal to A bar into B bar plus C bar. So this is the simplified expression. Okay, So here we group all the don't care with the max terms. In the previous example also we group all the don't cares, but it is not necessary to group all the don't cares, but in these two examples all the don't cares are needed for grouping. That's why they are grouped. Okay, consider another example. F is equal to sigma m of 3, 4, 8, 9, 12, 14 and D is equal to sigma m of 0, 1, 6, 13, 15. Okay, so first we can draw the K-map. So this is the K-map. In this K-map we can mark the minterms and don't cares. So first mark the minterms 3, 4, 8, 9, 12, 14. Okay, then mark the don't cares. X, don't cares as X. So 0, 1, 6, 13, 15. Right? Next we can perform grouping. So first group is these two and these two form a quad. Then second group is these two and these two form again a quad. So we get two quads, and to pair this one we take a don't care, so we get a pair. Okay, so here we group all the ones, but here we have two don't cares that is not grouped, so it is not necessary to group all the don't cares. We take only those don't cares that is needed for grouping with 1. Okay, so here the expression for this quad is, here A is cancelled, B, then in this case C is cancelled, D bar, B D bar. Then for this quad A is cancelled, B bar, then D is cancelled, C bar, B bar, C bar is the expression. Then next expression for this pair, here it is A bar, B bar, here 0, 1, 1, 1, so 0, 1 cancelled, we have D. Okay, so the simplified expression is F is equal to B bar, C bar plus B bar, D bar plus A bar, B bar, D. So this is the simplified expression. Okay, so this is all about the don't cares. So don't cares are the unspecified minterms or the max terms. They are marked as X in the K-map, and while mapping we consider that don't cares also, but it is not necessary to group all the don't cares. We consider only those needed for mapping with 1 or 0, 1 in the case of minterms and 0 in the case of max terms. Okay, so that's all about the don't cares. Thanks for listening.